All right, so what we're going to take a look at here is the chain rule. The good news is this is the last rule for taking derivatives you need. Yahoo! After this, you got them all. There are 4 of them. Power rule, product rule, quotient rule, chain rule. Okay, so we have looked at a variety of situations. One situation we have not looked at yet is stuff like y equals x squared plus 7x minus 3 raised to the 96th power. Yes, you could multiply that out. Multiplying that thing times itself 96 times and combining like terms, that'd probably take all the way till the end of the semester, wouldn't it? Now, there's got to be an easier way. There is. And if I recall correctly, we kind of waded into this a little bit the last class. And what we had talked about was the idea that if you have y is equal to a function with a function inside of it. Did we talk about this the other day with composite functions? I'm thinking. People are kind of giving me blank looks like, yeah, if we did, I don't want to admit to it. Okay? The idea of this notation is the f represents a function on the outside. Oh, here it is. Okay? So the f represents something on the outside, and the g represents something on the inside. How does that work with this function we have over here? Well, inside is easy to spot. The inside is that x squared business, isn't it? So you walk up to this and you say, okay, there's what's inside. I'm going to label that as g of x. Then, what's on the outside? The 96th power, isn't it? That is going to be the outside function. We could, using the definition of a derivative, that limit as h goes to 0 and all that razzle-dazzle, we could come up with the chain rule using that. But hey, that would take most of class. And we've got other places to go. So what winds up being the case is the derivative is going to be f prime of g of x times g prime of x. I'm going to show you something here that is wrong, and I'm going to do it in red, a little skull and crossbones. Okay? To try and emphasize that this is not good. Don't do this. Now you know I went into math instead of art. Okay? What people will oftentimes do is they will say, well, the derivative is going to be this 96, and when I bring it down, the exponent is going to be 95, and that is perfectly proper. That is a power rule move, isn't it? And then on the inside, they take the derivative, 2x plus 7. Now, the product rule, they've executed it correctly. The power rule, they've executed it correctly, but didn't quite do it at the right place. Okay? This is, shall we say, wrong. Well, it won't write that for me. Let's see if we can get it to right. Okay, so it's not going to do that. It doesn't want to admit to wrongness. It's just in red. It's not right. This is wrong. Don't ever do this. And every semester, people try it to see if I'm still serious about it being wrong. And every time they try it, it's still wrong. Okay? The cool thing about math is when they say something, they mean it. And when they say it, they stick by it. The way this is actually done, the derivative equals. Okay, looking in the upper right corner, the inside stuff does that change or does that stay the same? See that g of x? That still stays g of x, doesn't it? So to protect yourself, write down the inside stuff first. There. There's the f or the g part. Does that make sense? Now, looking at the rule outside of that, the stuff going on outside of it is the derivative of the outside function, isn't it? Well, the derivative of the outside function is going to be bring down to 96 and put your exponent of 95. Oh, well, they kind of did that in the wrong version, didn't they? Do you see the 96 out front, the 95 up? But what did they mess up? What's inside? It shouldn't be the 2x plus 7 yet, should it? Should still be the x squared plus 7x minus 3. So rewrite the inside first so you're not tempted to do this. Then, after you have the outside part with the derivative, now you do the derivative of the inside, and the derivative of the inside is the 2x plus 7. That is what the derivative looks like. Now, another way that people will mess this up is they will take, and once again, what I'm going to show you here is wrong. I'm just warning you of what people do, trying to create their own world of math. They'll take this and they'll multiply it times the stuff inside. But you can't multiply those two things together until you've done what? Remember, please excuse my dear Aunt Sally. Please is do the stuff in the parentheses. Nothing to do in either set of parentheses. What comes next? The exponents. So before you multiply by the 2x plus 7, you have to take the x squared plus 7x minus 3 and raise it to the 95th power. Brad's looking at me, oh my gosh, no, we will never do that. Okay? We will leave it like this, and everything we do will be from this form. Don't ever try to take the 2x plus 7 stuff and multiply it times the stuff inside. It doesn't work. Okay? So those are the two big mess-ups with this. Having warned you about where the mess-ups occur, it's okay to move on to another one? Let's take a look at something like this. Let's say we have y equals the cube root of 3x to the 7th minus 16x to the 4th plus e to the 5th. And that 4 isn't looking so easy to read there. So let's see if we can get something neater in there. Okay, real fair question. Not for today's quiz, but for next week. Real fair question on next week's quiz is, what's the derivative? Well, the first thing I'm going to do is I'm going to write this in a form where it's easier, bless you, to take the derivative of this. And that form is going to be by putting, now that you have an exponent, this works just like the last one, doesn't it? Yeah, this is back to easy peasy. Okay, so what I'm going to do first, to keep from doing the wrong thing, I'm going to write down whatever's inside, the 3x to the 7th minus the 16x to the 4th plus e to the 5th. Got it. That's okay. It's on the inside. Now I'm going to do the power rule with the stuff on the outside, which means bring the exponent of 1/3 out front. And the new exponent is going to be reduced by 1. In other words, subtract 1. 1/3 minus 1 is the same thing as 1/3 minus 3/3, isn't it? 1/3 minus 3/3 is negative 2/3. Does that make sense? Now, times. What comes next? Now we do the derivative of the inside step by step. The derivative of 3x to the 7th is going to be 21 x to the 6th minus the 16x to the 4th is going to be 64 x cubed. What's the derivative of e to the 5th? Is it 5e to the 4th? Somebody said 0. Where on earth would you get 0? Oh, e to the 5th is a number, isn't it? Well, how do I know it's a number? Can you turn your calculator on and press E, raised to the 5th, and bing, it gives you back a decimal? That means it's a number. Way to go. The derivative of e to the 5th is 0. And you might be sitting there thinking, geez, I didn't know that. That's fine. That's why you're here today. If you knew everything already, there's no sense being here. Okay? And you're done. Walk away from it. Don't mess with it. Okay? I've learned the hard way and tried to encourage my kids, especially on a farm where you got a zillion things going on mechanically and stuff. If it ain't broke, don't fix it. Okay? Because if it's already running and you try and fix it, what's probably going to happen? You're going to break it. Okay? That is absolutely fine the way it is. Walk away from it. Put your hands in your pocket if you must. Don't mess with it. That's done. Does that one make sense? Let's go after another one. Say we have something like this. Y equals x squared plus 7x times the 5th root of 16x to the 4th minus 8x. There. So there it is. And we need to compute the derivative of this. So y prime equals. Okay, well, let's see here. What's the overall thing going on with this function? Is the 5th root the main event, or is that just part of it? That's just part of it, isn't it? The main thing that's going on is you've got that x squared plus 7x times that 5th root stuff, don't you? Do you see that? You have this piece times this piece. Ah, does that bring back memories from the good old days? What's the main rule that's going to be running a derivative? It's okay, don't be shy. Show off your brains. What's it going to be? We got two things multiplied together. It's a product rule. Does that make sense? Everybody see that one? Okay, so we're going to need an f prime times a g plus f times g prime. Okay, so I've got it set up. And now we're just going to take it piece by piece by piece. F prime, well, that's pretty easy. That's 2x plus 7. G. I'm going to rewrite this a little bit because looking down toward the end of the thing, I've got to take its derivative. So I'm going to put this in a format that's easier to deal with when it comes time to take the derivative. This is going to be a 16x to the 4th minus 8x raised to what power? The 1/5. Plus. Now, f, well, we just copy that down. That's going to be this x squared plus the 7x. Ta-da! Everything's going smoothly so far. Old hat stuff. Uh-oh, we got to take the derivative of g. What rule do we need to use to take the derivative of g? It's a chain rule, isn't it? You mean you can use the chain rule inside of the product rule? You can, and you can use the product rule inside of the chain rule, and they can get all mixed up in every which direction. Okay, so let's see here. Oh, remember I rewrote it like this, which is hopefully going to make it easier to look at and do the derivative. The chain rule says first thing I'm going to do is I'm going to put my 16x to the 4th minus 8x inside. So the inside's taken care of. Now, what are we going to do with the outside? We're going to put the 1/5 out front. And it's going to get a new exponent of -4/5. Everybody okay with where that came from? 1/5 minus 5/5 is a -4/5. Okay, so we've got that done. We're done now, right? No, we got to also take the derivative now of the inside. So 16 times 4 is 64, x cubed, and the derivative of 8x is 8, and there you have it done. There is one little tweak I would suggest doing to this. There are two things, but we'll talk about one of them first. See that 1/5 kind of buried in the middle of all that stuff? That'd be easy to overlook, wouldn't it? What I'm going to do is I'm going to take the 1/5, and I'm going to still keep my plus sign, but I'm going to put the 1/5 up front like that, so that coefficient doesn't get lost in the middle of all those polynomials. Does that make sense to everybody? Is it wrong to leave it the other way? No, it'll work fine until you overlook the 1/5. The other thing you might want to do is to take this 64x cubed minus 8 and put it in front so that you have your two pieces that both have exponents of 1, and then at the end you've got that piece that has the exponent of -4/5. The reason that I would put that last is that -4/5 stands out more if it's hanging off the back end of the problem than if it's buried in the middle of the problem. Those are just kind of safety measures. Those are put on your seatbelt type stuff. Are you okay? Processing? Want to try one on your own here? Or chat with the people next to you while you're working on it? Let's say we have something like this. Well, not y prime. We're going to have to find y prime, aren't we? Let's say that y is equal to 12x squared plus 9x minus 3 times the square root of 17x squared plus 8x minus pi. Go get them. Figure out what the derivative is. If you want to chat with the folks around you, have at it. If you want to just take it on yourself, go get them. So I got a basic setup, so I know what my plan is for the game. Hey, are you finding that for the most part you just look at the problem and you write down the answer? Is that kind of scary? You're doing the calculus in your head basically, aren't you? Yeah, how about that? Calculus isn't hard, you can just do it in your head. Don't tell that to too many people. If you admit to that, they're going to label you a geek or a nerd or something like that. And then your whole circle of friends changes. You ready for the last part to come down? Okay. I'm going to do this move where I reposition the plus sign, because when I look at taking the derivative of this, we're going to get a coefficient of 1/2 out front, aren't we? And I'm just going to put this to the very front. So we have my 1/2. Now the stuff inside stays the same. 17x squared plus 8x minus pi all stays the same, but what does the exponent on it become? Negative 1/2. Yeah. Okay. So it's going to be to the negative 1/2. Then we take the derivative of the inside, 34x plus 8, and the derivative of minus pi is 0, because pi is just a number, and there it is. Now, you ready for something? Spoiler alert, this is just going to ruin your quotient rule day. Oh no, what's he going to do to us? Okay, everybody good with this one? Let's jump into another one. Let's have something like this. Y is equal to x to the 4th minus 7 over 3x squared plus 6x minus 2. Well, gosh, that's clearly a quotient rule, isn't it? Not so clearly to me, because this can be rewritten as x to the 4th minus 7 times is 3x squared plus 6x minus 2 raised to the negative 1. Oh man, what just happened to the quotient rule? Now that you know the chain rule, do you really need the quotient rule? No, you can use a sneak attack around it, can't you? Get out of here, really, Chuck? Really? Now, I'll admit to you, on test 2, I'm going to put down a question something like this, and I'm going to say you must use the quotient rule only. Why is Chuck doing that? To be mean? Because I want to make sure you can still use the quotient rule, because guess what most people do when they get stuff like this? They just use the product rule, throw in the chain rule, and they're done. So a second way to do this, other than the quotient rule, is to say, you know what? I really like that product rule. I'll stick with that. Y prime equals, you're going to have your f prime g. Are people getting tired of seeing the f prime g plus fg prime? I'm hoping so. I'm hoping it's kind of burned into your memory. Okay, now this is going to be fairly straightforward to do. This is going to be 4x to the 3rd. That's the derivative of the first part. The second part stays the same, 3x squared plus 6x minus 2 to the negative 1. Just copy it down again. Plus, and I'm going to save some space because I've learned coefficients start coming out of here. I'm going to write my x to the 4th minus 7. Now comes the chain rule. This is where we save that space for a coefficient, because what coefficient is going to land out front of that x to the 4th minus 7? It's going to be a negative 1, isn't it? So I'm going to put a negative 1 here. Now, what you'll soon learn to do is plus a negative 1 really means we're doing what with that whole second chunk? Just subtracting, aren't we? So what you'll soon learn to do, probably already know how to do, is just change that to a minus. Not because the product rule is plus or minus, but because we have plus or minus. Okay? Then we're going to write down the stuff inside. You don't change the stuff inside. What's the new exponent going to be? Negative 2, isn't it? Times, now we do the derivative of the stuff inside. And there you have it. So if you get on a quiz, test, final exam, or whatever, and you're just asked do the derivative, or actually won't be asked do the derivative, you'll be asked what's the rate of change or something like that, how are things changing, because that's what this is really talking about. And oh crud, I forgot that quotient rule. I don't need it. I'll just use the product rule and the chain rule. Does that make sense to everybody? How about that? Hopefully I just made your day. Okay, we will call it quits with that for now.